So today we're going to cover Chapter 8, Section 4. And today we're going to see several more theorems. And they're all going to be based off of proportions. So the first one is called the triangle proportionality theorem. And this one states that if a line is parallel to one side of a triangle, it intersects the other two sides, then it divides the two sides proportionally. So the two sides in this proportion, or this triangle that are parallel, would be EB is parallel to DC. And that's what was given to us in our if-then statement. So that's what it's stating up here. If a line parallel to one side of a triangle, which is here, and then it intersects the other two sides. So the other two sides they're referring to is over here, and it's intersecting the two sides. It's going to divide that side proportionally. So it'll make this little piece AB proportional to BC, and then the same thing over here. Now, the way that the proportion is given to you here, what they've done is they've put top right over bottom right, and that's what's here, the AB over BC. And then they also took the left top and put it over the left bottom. And that's the way that they're setting up their proportion. So they're putting both of the top sides on the top of the fractions, and then both of the bottom sides in the bottom. Now, you could also do it left to right. So you could also do, for example, or right to left, either way. You could also set up your proportion as AE over AB. So this would be left top over right top. And then you could do right bottom. That's right. So then ED over BC. So this would be left bottom over right bottom. You could set it up this way also. Just remember, stay consistent of how you're going to do it. So you can either do the tops up and down and the bottoms up and down, or you could do the tops in the top and the bottoms in the bottom. Either way, you're still going to get the same answer. Because remember, these are similar triangles. So for example, let me redraw the triangle here. If we're told that these two sides are parallel, then that tells me that I've got corresponding angles here and here. So by my angle similarity postulate or theorem, I know this little one is similar to the big blue one because I do have two angle pairs that are congruent. I also have this one at the tippy top that they share. So I can find for sure two angle pairs if those sides are parallel, then I can find two angle pairs that are congruent. The next one is the converse of this theorem. So the converse of the triangle proportionality theorem, remember this is where we switch the if and the then. So now instead, they're showing you that the pieces are proportional, and you can prove that the lines are parallel. So again, if they showed you that this top piece over this bottom piece, so they're doing top over bottom in their proportion here. So they're doing top right over bottom right, and then top left over bottom left. So again, the tops of the fraction are the pieces that are on the top. So these are here, and that's where you're getting these numbers. And then they're putting over the bottom pieces. Then you can prove, if these are proportional, that these two sides, or the two sides of the triangle, are parallel. Let's try an example of this. Again, you can also go the other way. You can go side to side. So keep in mind, you could set your proportion up just like we did in the other one. Anybody still need this slide?
Yes.
Okay. So example 1 is using this proportionality theorem. So let's go ahead first and complete the proportion. So they've already set up the first one. So they're doing CD over DA. So here they're doing, if you flipped it around, it would be top over bottom, but the way it's looking, it looks like it's bottom over top. So just match. So we're going to put this over this. So we would say CE over EB. So now let's add in the numbers that they're giving us. So they gave us the length of CD, it's 3. They gave us the length of DA, it's 6. They gave us the length of DE, it's 3.5. And they want us to find this bottom piece of the triangle. Now, remember, these are similar triangles. So again, if I pull them apart, this is the little one, the CDE, and then I have the larger one, ABC. And if I add the numbers in here, this one's 3, 3.5, and then this side I can find by adding the 6 plus 3, and it's 9. So I got this by adding 3 plus 6. Now I don't know this side. Now these are similar triangles because they both share angle C. And then I also see that they're parallel, so I also know I have corresponding congruent angles here. And the same thing over here. So it doesn't matter which one I choose. I have two similar triangles. So now I can match the sides. So I can match side ED with BA, and then I'm going to match CD with AC. So my portion to solve part B is going to be 3 to 9. I guess I can do it in green because that's what I highlighted. 3 to 9, and then I'll do the blue. 3.5 to X. Now, you can either choose to solve your proportion this way. You can't cross simplify because we have to cross multiply, but I could reduce the 3/9. I can make this 1/3. And now cross multiply. So I'm going to multiply 1 times X and 3 times 3.5. So my answer here is X is equal to 10.5. So the length of AB is 10.5. Let me redraw the triangles for part C. So again, if I EDC, it might be better if I'll pull it apart and then I can redraw it together also. BAC. So they gave me CB is 12. They told me EB over here, this is 8. And if the whole thing is 12, I can find the length of CE by doing 12 minus 8, and I get 4. So this is 4. And now they also gave me that CD is 6. They want me to find the length of DA. And DA is this little piece here. So I can go about doing this couple different ways. So what I could do first is just do it as if it's a proportion without similar triangles. So let me draw it back together. So B, A, E, D, C. So this is 8, this is 4, DA I'm looking for, and CD is 6. So for this question, it's better if I leave them apart. So what I can do is I can either go top with top, bottom with bottom, or bottom to top, either way, or top to bottom. So if I go top over top, so 8 over x, so these two together, and then I could put these two together. Cross multiply and divide. If you want to simplify the 4, 6, you can. You can also just leave it alone. Divide, and x equals 12. Now, keep in mind, we could have also solved it by doing top 8 over the 4 underneath it, and then the top x over the 6 underneath it. Either way, you're going to get the same answer. So either one of these will work. Memorize one of these and figure out which one you want. Either doing top over bottom, or do tops in one fraction and bottoms in the other. Pretty good? Okay. Next, another theorem. Now this time it's not in a triangle. It's just 3 lines that are parallel. So if 3 parallel lines intersect 2 transversals, those are my transversals in blue, then they're going to divide the transversals proportionally. So they've set up one of my proportions here, and they're doing this right top over this right bottom. So these are all tops, and these are all bottoms. So then left top over left bottom. And just keep in mind, if you would have rather flipped it, you could. Now, we can also go top over top. So we could do AF over BC, and then FE over CD. You can also solve it this way. Or you can go bottom to top. Like you could put the bottom, EF, and then the top, and then the bottom, and then the top. Either way, just find how you're going to do it and stay consistent. It might be easier to just do it like they do and put the tops in the top of the fraction and put the bottoms in the bottom. That might be the easier way to memorize it. All right, let's try example 2. We're going to apply this theorem. Okay, so we have our 3 parallel lines and we have our 2 transversals. So for part A, I'll write the numbers into my figure in red. So A equals 2, B equals 3, C equals 5. It wants me to find D. So actually I can just leave it as a D, not an X. So again, let's just do the technique of top over bottom, top over bottom. And we'll cross multiply and divide. So 2 times D, 5 times 3, divide. D is equal to 15 over 2. When I divide that, I get 7.5 or 7.5. So be aware that all of these are the same thing. And generally, when we're trying to identify a segment, they would expect you to divide it and either make it a mixed number or a decimal. All right, now I'm going to do part B in blue. So this was in red. I'll do this one. I'm going to label the sides in blue. So A now is a 4, B is an 8, C is still a 5. Now this time, instead of finding D, they want C plus D, but I'm going to do it the same way. I'm going to find D, but then I'm going to add it to C. So again, I'm going to do top over bottom, top over bottom. I'm going to find D, but then I'm going to add it to the C. If you want to simplify this, you could. So I could solve it as it is and get 4D equals 40, divide by 4, and get D equals 10. If you want to reduce a fraction that's in here, you could reduce that to 1/2, and then it goes right to your answer. Now, the question did not ask for just D, it wants C plus D, and I knew C equaled 5, so now I'm going to do 5 plus the D I just got, and my answer is 15. Yes? Mm-hmm. Next slide is a theorem. Again, the number is not important to us, but the name is. So this is the triangle angle bisector theorem. So this states that if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So here is my ray in red that has bisected this angle. And the way that I know that that angle was bisected is because it's got the congruency marks here. You can see that this is congruent to this, so I knew that that angle was split into 2 equal parts. So now the little pieces where the ray comes out, this AD and this DB, I can go ahead and put those pieces that have been broken apart, and then the AD is going to be with its side that is in the same triangle, if you wanted to think of separated it. So that piece that it split goes with the side that it's next to, same thing here, and it's going to go with the CB. Now, we can also set this up with the sides. So like if you think of this as being like 2 different triangles, you can have the piece that it split, the AD, over its side that it's next to. And then same thing here, the side that split, the DB, and then put it with the side that it's with, or right next to. So you can set it up that way. So let's try to apply this in the last example. Remember, we can choose to set up our proportion. Last example. It wants us to find the value of x, which is this whole side here. Now, the proportion I just learned didn't teach me to find the whole thing. It wanted me to break it apart into the little pieces. So to make my problem a little bit easier for myself, I'm going to say that this little piece that this ray bisects, this angle here, and it splits these 2 segments up, I'm going to call this one segment that doesn't have a number next to it, I'm going to call it y. So, and we can either choose to do this piece, the segment that it split, over its side that it's next to. So we could do 10 over 12. And then I'm going to take the other piece that resulted from the ray bisecting the angle and put it over its side that it's next to. So here I could do 10 over 12, and then y over 24. Now, if you want to reduce the 10 over 12, you could simplify this to 5 over 6. And now we can solve the proportion. Or you could leave it alone. It's up to you. So if I simplify it, I would do 6 times y, 5 times 24, and get 120. Divide by 6, and y equals 20. Now, if I would have solved it without simplifying, I would have gotten 204, I would have gotten 12y equals 240, divide by 12, and y still equals 20. Either way. Now, another way you can set it up is you could also do these two sides over each other, and then the two sides that got split. So put the 10 over the y. So either way, we get 12y equals 240, divide, y equals 20. Now, it didn't ask for y, remember it asked for x. So if I knew that it was 10 plus the y I just found, 10 plus 20, and x equals 30. So if I put the 20 here and then go back and add it, x equals 30. So again, choose how you're going to set up your proportions and just stay consistent. Any questions?